everyone. Today we're going to continue chapter 2. So we're going to discuss prefixes and equalities today. So one example of why we need prefixes, let's say you go to the eye doctor or the ophthalmologist and they take photographs of the retina of your eye. Now your eye is really, really small, right? And the nerves in your eye are even smaller. Your iris is really small. So ophthalmologists have to use really small units. So for instance, they're not going to use a meter stick to measure your eye. Your eye is a lot smaller than a meter. So they'll probably want to decrease the size of the unit. So again, a prefix can be placed in front of any unit to increase or decrease its size by some factor of 10. Now, in chemistry, we often work with really small units similar to ophthalmology. Probably not as small, but similar. So as an example, we might use prefixes such as milli or micro in order to make a unit smaller. So a milligram is 1/1000th of a gram. And a microgram is 1/1,000,000th of a gram. So we would be working with really small amounts of something in this case. So you'll notice some abbreviations here. So for milligram, we write mg. And for microgram, there's a couple of different options. We could write this Greek symbol mu to represent micro, or we can just write MC for micro in front of gram. Now, we could also put these prefixes in front of other units, like the meter. We could have millimeters or micrometers, or really any unit. So let's talk about prefixes that increase the size of the unit. And let's use the example of computer memory. So we typically talk about the size of a document or an app or some software in terms of bytes. But usually documents or softwares or apps are worth a lot of bytes of storage. So we might need to increase the size of this unit. So maybe we have a kilobyte, which is worth 1,000 bytes, or a megabyte, which is worth 1,000,000 bytes. And we can keep going. So a gigabyte, a terabyte, and a petabyte. Now, usually, or I think storage so far just goes up to a terabyte, but at least at the store, you know, there's certainly petabytes of information out there. Now, we could also add these prefixes to other units as well. So, for instance, in Europe, they measure distance in kilometers. Whereas here we measure things in terms of feet or yards. We might also have megagrams of mass. So off to the side, there's just some examples here of when we might use these prefixes. Now we can also write the size of each of these prefixes in scientific notation, which can be a little bit easier to write. So 1,000, for instance, there's 3 zeros there, so we can write that as 10 to the 3rd. 1,000,000 can be written as 10 to the 6th. Let's see, what's next? A billion? So that's 10 to the 9th. And we're just going up by 3 each time. Now, what about prefixes that decrease the size of a unit? So these are what we'll be seeing more often in chemistry. All right, so we have deci, which is 1/10 the size of a unit. So we could also write that as 0.1 or 1/10. Or we could also represent that as 10 to the negative 1. Centi, we most often use with meters, so a centimeter, and that's 1/100th of whatever we're measuring. So we could write that as 1/100 or 0.01 or 10 to the negative 2. All right, and then milli, we already said is 1/1000th or 0.001 or 10 to the negative 3. And then we also went over micro, and micro is 1/1,000,000th. So we could write that as 0.000001, or we could write that as 10 to the negative 6. And then beyond that, we have nano, pico, and femto, which we don't often see just because those are really, really small. But as you go on in science, you might come across those prefixes, so it's good to know them. Now, I do expect you to know the majority of these prefixes. In fact, I would say just memorize them all. I do have flashcards up on the website under study guides in modules. So if you go to modules, study guides, you'll find flashcards for prefixes. So those are online, so you don't have to download anything or print anything. And it's just useful to go through those and make sure you know all of these different prefixes. Okay, so let's show the relationship of a prefix to a unit. So the relationship of a prefix to a unit can be expressed by replacing the prefix with its numerical value. So for example, when the prefix kilo in kilometer is replaced with its value of 1,000, we find that a kilometer is equal to 1,000 meters. So remember, kilo is one of the prefixes that increases the size of the unit. So instead of saying I have 1,000 meters or I measured 1,000 meters, you could say that you have 1 kilometer or kilometer. And it's the same for other units as well. So if you have 1 kiloliter, you have 1,000 liters. So we're just replacing kilo with 1,000. And same for grams. If you have a kilogram, you have 1,000 grams. And again, remember we can write this in scientific notation. So 1,000 is also written as 10 to the third. Now, one place that you might have seen prefixes is on the sides of your food packaging. So where they list, for instance, how many carbohydrates there are or how much of different vitamins there are. They might list things in, for instance, milligrams or micrograms. Now, the U.S. Food and Drug Administration, uses metric prefixes to express amounts of daily nutrient requirements. So for instance, we require 1 gram of calcium. So calcium is really good for your bones and your teeth. Now compare that to copper. So copper, you only need 2 milligrams. We also require a very, very small amount of iodine, 150 micrograms. So that's even smaller than or less than how much copper we need. Now, iodine is really important for your thyroids. Your thyroids are kind of along the side of your neck, and those require iodine, and iodine is actually also used as a treatment to cure thyroid cancer, etc. And actually, if you have a thing of salt at home, it's iodized, and that just means it has iodine in it. Let's see, we also require some iron, magnesium, niacin, so those are all in terms of milligrams. Now, sodium, we actually require quite a bit more. So we require 2.4 grams of sodium. Now, that doesn't mean you should go pouring salt on everything, because that's not good, but we do require some sodium. So you can see these varying amounts and get an idea of how much of each we need. Okay, so let's do a quick learning check, and we'll practice using these prefixes. So we're going to fill in the blanks with the correct prefix. Okay, so let's do this one together. Now in A, we have 1,000 meters. So instead of writing 1,000 meters, we could use a prefix in place of 1,000. So which prefix would we use? Kilo. So we would just put a symbol K there. So 1,000 meters is equal to 1 kilometer or kilometer. What about B? We have 1 times 10 to the negative 3 grams. So instead of writing 1 times 10 to the negative 3, we could use a prefix. Now, the other way to write 1 times 10 to the third, or negative 3, that's also equivalent to 1 over 1,000. And which prefix were we using for that? Milli, so that would be 1 milligram. And what about 0.01 meters? Instead of writing 0.01, we can use a prefix, and 0.01 is also equal to 1 over 100. So which prefix could we use there? Centi. So if we have 0.01 meters, or 1 out of 100 meters, that means we have 1 centimeter. And then here are the solutions for each, if you want to study those later. So going back to the example of the ophthalmologist. Ophthalmologists, again, measure the size of your eye, so the diameter of your eye's retina. And for that, they use centimeters, which is a smaller unit. And then a surgeon will measure the length of a nerve in your eye in millimeters. So if we look down below, there are some equalities written out. And these equalities describe the same length, just in different units. So for instance, 1 meter is equal to 100 centimeters. So there are 100 centimeters in 1 meter. And we could rewrite 100 as 1 times 10 to the negative 2. Another equality, if we have 1 meter, we also have 1,000 millimeters. So there are 1,000 millimeters in a meter. And let's say we want to figure out the equality between centimeters and millimeters. So let's look at these two here. So if 100 centimeters equals a meter and 1,000 millimeters also equals a meter, then 100 centimeters equals 1,000 millimeters. But we can simplify this, right? So let's divide both sides by 100. We'll just simplify the equality here. So that tells us that 1 centimeter is equal to, let's see, so 1,000 divided by 100. So how many times does 100 go into 1,000? 10 times. You could also just kind of scratch out some of these zeros here, and that leaves us 10. That's another way to do it. All right, so then we have 1 centimeter is equal to 10 millimeters. All right, so these equalities can come in handy when you're doing conversions between units. So we'll start talking about that later on. All right, let's do another quick learning check. Let's identify the larger unit in each of the following. So if we're comparing millimeters to centimeters, which one is larger? So remember, milli is 1 out of 1,000, whereas centi is 1 out of 100. So this is milli, and this is centi. So which one is larger? Centi, right? All right, now what about B? If we're comparing kilograms to centigrams, which one is larger? So remember, kilo is equal to 1,000 of something, whereas centi, we said already, is 1 out of 100. So which one is larger? The kilogram, and it's larger by quite a bit. All right, so now C, let's say we're comparing milliliters to microliters. So we already said milli is worth 1 out of 1,000. Micro is 1 out of 1 million. So which one is larger? The milliliter. And what about D? We have kiloliters and microliters. Which one is larger? The kiloliter. So we already said kilo is worth 1,000 and micro is only worth 1 out of 1,000,000. All right. And here's a solution slide if you need that later. Now on Canvas, I posted a conversion worksheet. So this worksheet kind of steps you through different equalities. So for instance, it might ask you what 1 deciliter is equal to in terms of liters. So you'll have to fill in the blank. Now just a hint on that worksheet, 1 milliliter is equal to 1 centimeter cubed. So that will help on that worksheet. So I do normally encourage you to work with others in the class, but of course we're teaching online this quarter. So this is something you can work through on your own. And then I also posted the key so you can see if you did it right. And this is for you to keep as a study guide. So this will help you learn the prefixes and kind of step you through those in a little bit more detail. All right, so I think we'll end things there today. Next time, we'll go over conversion factors, so how to convert from one unit to another unit. So I will see you then.